Hello all and welcome to session 2 in series 3 of No Time to Waste. My name's Sharon Rundle-Teely and I'm co-hosting today with Ricky Hersberg. I'm from social marketing at Griffith and work with a team of change agents who've come to understand just how hard it is to enact change in a space that is actually characterised by systems, complex structures that are built around us, our institutions and governance processes that once we've set them up, make it very hard to unwind. And in a situation like waste, where we know that there's no time left, we've got a lot to do to untangle the complex spider's web that we've actually come to build. So on behalf of my partners who have actually come together to bring us series 3 of No Time to Waste, which includes Hongik University, Green Technology Centre in Korea, and Plastics Oceans Australasia, I'm really delighted to have you in the room today. Now, I'd actually like to invite you to go into the chat channel, say hello to other participants in the room, but use this to actually pose questions. And so our team will help to voice and get your questions across. And towards the end of the session, we'll make sure that our speakers today actually also have these questions to actually help keep this conversation going. So with no further ado, I'll hand over to Ricky, who'll start to work on today's session. Thanks, Ricky.
Thank you, Sharon, and welcome everybody, including our special guests and the team and everyone here. Dr. Yoonah Jeong, Ms. Christine Hodges and Richard Romanowski. Of course, I need to begin today by acknowledging the traditional custodians of the land on which we meet today and pay my respects to their elders past and present. I extend that respect to Aboriginal and Torres Strait Island people here today. Just quickly to give you a little segue in, which I usually do when we do our series. Last year when POA created the No Time to Waste series, who would have thought that webinars like this are still going strong, and it seems to be that they're going to be lingering with us for quite a long time. And for those of you that are based in Melbourne, you must all be feeling relieved coming out of lockdown, like I am. For our fellow Australians in other states, where freedom of movement for some of you is restricted, we feel your pain and hope that today's session will offer you a little bit of distraction and some light relief. So of course, as Sharon mentioned, our session today is focusing on market systems. What is a market system? We will find out more about that and why is it relevant with our series. And as we all know, there is no time to waste. So let's start unraveling that spider's web. And it's now my great pleasure to introduce our first guest speaker, which is Dr. Jeong. Dr. Jeong is a researcher at the Korean Institute of Civil Engineering and Building Technology, Human Research Area which is a research area in the conversion of biomass and food waste to biofuel. In her talk, we are going to find out how South Korea became the world's best food waste recycling country and learn how cutting-edge climate technology is effectively recycling food waste in South Korea. Her title for today's presentation is aptly named Cutting-Edge Climate Technology for Effective Food Waste Recycling in South Korea. Welcome, and over to you, Yoonah.
Thanks. Thanks for this opportunity to talk to this session on No Time to Waste today. I'm going to share my screen. So the title of the presentation is Food Waste as a Renewable Fuel, a case study of Korea. I want to give you a brief description of the process that we work through in Korea. I'm going to start with a background about food waste in Korea. About 14,000 tons of food waste is generated every day. According to the Ministry of Environment, about 97% of generated food waste is recycled. About 45% of food waste is converted into animal feed. About 30% is recycled into compost. Another 15% is gasified to produce biogas. And this high recycling rate is achievable because of the collection and treatment system. We have a distinctive treatment system. Food waste is collected separately, and these are not mixed with other types of waste. But current recycling methods face limitations, and both food waste-based animal feed and compost have been piled up at the treatment facility. This is because animal feed based on food waste has been pointed out as one of the factors which help the spreading of disease such as avian influenza and African swine fever. and high salt content in food waste is not efficiently removed, and this leads to poor quality of compost. In the case of biogas, this is actually a practical approach for food waste, but the final product from gasification showed poor quality and low efficiency at the moment. And currently, only a small portion of food waste is gasified. We have several ongoing issues related to food waste. First, we need an alternative recycling method for food waste. Secondly, there is a policy requirement for renewable energy. Renewable portfolio standard, RPS, require electric providers to provide a specified percentage of electricity with eligible renewable resources. To meet RPS requirements, wood pellets have been applied for coke conversion with coal in a thermal power plant. As you can see in this figure, the target renewable supply obligation is 9% for this year, but I was told we are doing about 6% at the moment. And using wood pellet is costly because over 90% of wood pellet has been imported. The last issue we need to consider is the reduction of greenhouse gas emissions. Running a thermal power plant is one of the main sources of greenhouse gas emissions. Co-firing biomass with coal reduces the consumption of fossil fuel and greenhouse gas emissions. Therefore, we aim to propose an alternative treatment approach for food waste to ensure future sustainability. In our research, food waste is converted into renewable solid fuel. Here, main challenges are to satisfy the qualification of fuel, including calorific value, chlorine, ash, heavy metal content. What differs here is that we produce high quality food waste biochar. I am going to go into details on this process on the next slide. And this is a base workflow. Food wastes are collected in the food waste treatment facility, and these are dried and shredded. Dried food waste are put into pyrolyzer. Pyrolysis temperature is set to 300 or 400 or 500, and the retention time is 10 to 30 minutes. After pyrolysis, food waste biochar is produced and desalinated to lower chlorine content. Food waste biochar is dried to remove the remaining moisture, and the final product biochar is analyzed to make sure of its quality. I'm going to show you what we have achieved. First, the chlorine content in food waste was efficiently lowered by demineralization. And this is a critical issue in solid fuel because when biomass containing chlorine is combusted, it generates dioxin and dioxin-like substances, which are very hazardous. The chlorine content of raw food waste is 1 to 2%, and after pyrolysis, concentration increased to 2 to 4% because volatile metals in raw food waste are volatilized and overall mass is reduced. So relative chlorine concentration increased. The high concentration is lowered to 0.5% after demineralization. And I'm gonna skip the details of this figure and the experimental process, but the point here is that various pyrolysis and experimental processes have been tested to find out the most efficient reduction method for chlorine from food waste biochar. And calorific value is another critical factor in fuel because this implies the amount of energy produced based on fuel. And low ash content is desirable because high ash content in biochar leads to slagging and fouling in the plant facility. Several experimental settings were tested to achieve high calorific value and low ash content of food waste biochar. As you can see here, pyrolysis temperature of 500 Celsius degree and demineralization using Ca, where Ca means citric acid, and this is the most efficient method to obtain food waste biochar with high performance. And this calorific value of 5,000 kilocalorie per kilogram is similar to that of coal. We also consider other biomass, sludge from wastewater treatment plant. Sludges are usually employed in co-firing with coal, but high metal concentration and low calorific value have been problematic. So we thought a mixture of food waste and sludge may increase calorific value and lower heavy metal concentration. And we can see it here. and from the graph on the left side, with an increasing food waste ratio on the x-axis, and the calorific value of mixed biochar increased. And the graph on the right side, you can see here the heavy metal concentration decreased with increasing food waste ratio. So far, I have introduced the research we have worked on, but this is not going to work if we work alone. Converting waste into renewable energy requires the cooperation of regional government and electric providers. We have networks with electric provider and regional organizations. So far, we have focused on laboratory and pilot scale research, but talking about actual application of food waste biochar in the plant facility. This is my last slide. And the very beginning idea of this research is the food waste is an untapped energy resource with a large volume and high carbon content. We confirmed that food waste biochar meets the qualification criteria of fuel for coal-fired in thermoelectric power plant in many aspects. In addition, we also checked that combination of food waste and sludgy is promising. But we still have a long way to go. The energy efficiency and combustibility of food waste biochar in the plant needs to be tested. And we don't know the optimized ratio of biomass for co-firing. And of course, the life cycle assessment of food waste biochar is required to ensure that this is sustainable and environmental friendly. Lastly, we have regulatory issues. Currently, using food waste as solid fuel is inhibited in Korea. So we are talking with people in the regulatory and industrial sectors to sort out the better approach for food waste. That's it for my presentation, and I will be happy to answer your questions.
Thanks, Yoonah. Thanks so much for that. And I actually understand that you like dining. A little bird told me that you like dining out and going out to restaurants with your colleagues, and that instead of if there's any food left over, instead of leaving it there, that you actually make sure you can take the food for research later, of course, knowing that it's better to have no waste at all. But that's wonderful to know that you actually do practice what you preach. Before we hand over and move on to the next speaker, I did actually have one question that I wanted to ask you, because I find this really fascinating with your studies and what you're working on. And I wanted to ask you what you think the advantages are of using food waste biochar in a thermoelectric power plant compared to using wood pellets. And I just wondered if you could expand a little bit on that. I'm quite interested in that comparison.
Actually, wood pellet is a good material for co-firing, and that's why we use it at the moment. But the problem is we need large quantities, and it costs a lot. And the application of wood pellets generates a high amount of ash, which causes operational issues in plant facility. And we found that quality of food waste biochar is similar to wood pellet in terms of calorific value and chlorine, ash, heavy metal content in many aspects. But food waste biochar is an economic choice because a huge amount of food waste is generated every day, and we can use existing plant facility to produce food waste biochar. So it's more cheaper choice. And we think using food waste as a renewable fuel serves both environmental and social problems in the waste and energy sector. But actually, everyone needs to keep in mind that this research is based on lab and pilot scale at the moment. This is not actual plant scale research, so we are working with electricity providers and regional government to deal with this issue from a broader perspective.
Fantastic. Well, I hope it comes to fruition from the pilot stage, because it's obviously fantastic that over 90% of the food household waste is being used, which is terrific. So now what we'll do, thank you so much, and thank you very much for your presentation. I'm sure there'll be some questions at the end in the chat. So now I'd like to keep moving on, because we've got two more fantastic speakers. Our next speaker, who I actually know quite well, and she's actually on our technical advisory panel with Plastic Oceans Australasia, which we're very fortunate to have her, is Miss Christine Hodgkiss, and she's the Development Director at Veolia Australia and New Zealand. So Christine's been working with Veolia in the environmental services sector for over 20 years. And she's got a very multidiscipline reach across environmental assessment, compliance, project management, delivery, business development, strategic planning, operations, and so the story goes on. And she's obviously extremely passionate about driving and implementing effective, sustainable waste and resource management solutions. So I know that you're going to find her presentation today being a really great segue from Yoonah's, and she's talking about the role of energy from waste in a sustainable future for Australia. So over to you, Christine. Welcome.
Thank you, Ricky, and thank you everyone for the opportunity to speak with you today. So as Ricky said, I'd like to talk a little bit about the role of energy from waste at a much more helicopter view, I think, than the information and the detail that Yoonah went into in terms of food waste. But it's great to hear other initiatives that are happening around the globe. So in terms of what is energy from waste and where does it fit into the management of waste and resources, where energy from waste generally fits in is in the management of residual waste. So that's the waste after you've done all the recycling and all the other initiatives in terms of recovery, when what you've got left, trying to extract the value out of this last lot of material. So it's a technology which is used globally, it's quite commonly, but Australia has been quite slow to adopt this technology. And I really see it as one of the missing pieces in the puzzle in terms of Australia being able to move forward around our resource recovery and diversion from waste targets. So if we could go to the next slide, please. So what this shows is Veolia's reach in terms of energy from waste facilities globally. We operate over 65 across pretty much all continents. We've got the first one, which is currently under construction in Australia, but as you can see, there's many more facilities that are operational elsewhere in the globe, in particular in Europe and the UK. And I think part of the reason, I suppose, why you've got this different distribution around the globe is that there are lots of different market factors that affect that. So, for example, in Europe, in particular in the UK, to some extent, energy from waste has been utilised for over 20 years over there to help solve the problem of residual waste. And that's in part because there is a limited land available and therefore limited landfills available to be able to use that as a form of treatment of residual waste. Whereas in Australia, we're in a very different situation. We have an abundance of land. We have a resources-rich, earth that we have here. So we have very cheap coal-based electricity market, and we have plenty of, unfortunately, mine voids that can potentially be used for landfilling. So we are a little bit behind the 8 ball when it comes to adopting different technologies in terms of energy recovery compared to the rest of the world. But I really do see this as an opportunity for Australia to actually move forward in terms of increasing our resource recovery rates in general by adopting technology which has been used, tried and tested around the globe. So next slide, please. So if we can, we might be having the same difficulties, but I will carry on. So from a global perspective, I guess it's interesting to note and understand where we fit into the overall scheme of things. And when we look at overall recovery rates, we talk about recycling and energy recovery as two of the key elements that actually contribute to actually creating recovery across the board. And I guess where Australia sits in this global sort of picture is we're relatively good at recycling, so we have a reasonable recycling rate, but due to our heavy reliance on landfills, then we can't really we haven't been able to bridge that gap in terms of getting our overall recovery rates. I just thought that I would also add in here, hopefully you've got that back up again now. So in terms of our friends in Korea, and this sort of ties in well with what you're talking about, the opportunity to actually increase our recovery overall. Obviously, they're doing a really great job in terms of recycling and also have that element of energy from waste that really does contribute. And right at the top there, you can see countries that virtually have no waste to landfill because they're actually adopting a really strong mix of both recycling and recovery across the board. So next slide, please. So if we then look at the Australian landscape from a policy point of view, it is very complex. We have 3 layers of government that all have different roles to play in terms of how we manage our waste and our resources. So at a national level, we do have policies, we've got action plans, we have export bans that are gradually being implemented over the next few years, and we've also got net zero ambitions. So that's a really good platform for us to start from. I guess the challenge is that the waste that we manage, it's regulated at a state level, and so the state governments have a very big role to play in terms of determining what type of levers there are to encourage different technologies to be implemented. So it's pleasing that all states and territories do have waste strategies and action plans to try and help drive the direction that we're heading. And in terms of all mainland states, there's a specific policy on energy from waste, which does assist. I guess the challenges that we have is when there are discrepancies between those state approaches, then it can make it difficult to introduce technologies across the board. And what you can see here in terms of the figures there on the map are the landfill levy rates that are charged across different states. So you can see they range from some states that have no landfill levy whatsoever versus others that are close to $150 a tonne. And I guess that financial driver or lever has a real impact on the financial viability of introducing new technologies such as energy from waste. So it's really challenging, I guess, to introduce these sorts of new technologies without that support at a regulatory point of view in terms of financial levers. So I guess it's pleasing to see that there are some states, and in particular WA's, I suppose, ahead of the pack in terms of 2 facilities that are actually being constructed as we speak. So next slide, please. We start delving into, I suppose, a bit more detail around the statistics and where we're heading from a target point of view. So at a national level, we have targets for 2030 that fit really well with the waste hierarchy. So focusing on the avoidance of waste in the first place, how we can reduce that generation, as much as possible. Then moving further down and looking at the resource recovery rate. So how can we increase that resource recovery, and how can we remove waste from landfill? So the organic focus in terms of halving the waste to landfill is another key element. On the left-hand side there, you can see where we currently stand at the moment. So as I said before, from a recycling perspective, we're actually doing relatively well at 60%. But what's missing, I guess, in that equation is the energy recovery piece. So it's still only a very small contributor in terms of what we do at the moment. And the majority of that comes from landfill gas extraction. Because we have so many landfills, we do generate gas as a result of that, trying to capture that as much as possible to minimise the impact of landfills. But when that's the majority of the energy recovery that we're receiving, we're really not doing it in a very efficient way, and there's the opportunity for us to actually make that step change in terms of introducing more energy recovery facilities to actually improve that recovery overall. I guess just on the right-hand side there, just sort of trying to break that down a little bit more in terms of the different types of waste waste that we have. So from recyclables, in terms of your curbside recycling, it makes sense to use mechanical sorting processes. From an organic point of view, using the natural biological process to actually recover benefit from that. And I guess what we're talking about is what can we do in terms of that residual? So what's left over, and when there's appropriate calorific value that can be utilised out of that, then thermal treatment is a suitable option for that. So if we can move on to the next slide, please. So just talking about 2 of the most common types of energy recovery technologies. So there's thermal and biological. So from a thermal treatment process, technologies such as combustion, gasification and pyrolysis, which Yoonah spoke about a little bit earlier. So all of those are thermal processes, and they use differing levels of oxygen in the environment that they're occurring to produce steam or gas for energy production. Apologies if you can hear my children running down the hallway in the background. In terms of these different technologies, so combustion is a suitable process for mixed waste streams, and so that includes prepared fuel. Anything that has been processed to actually create a fuel can be used from a combustion point of view, whereas the other 2 require slightly more cleaner or homogeneous waste streams. So the example that Yoonah spoke about in terms of food waste, much more suitable for either gasification or pyrolysis. Now, in terms of biological treatment, these processes use the natural fermentation process of organic waste to actually break down the organic material, produce a biogas, again, for energy production. And as I mentioned before, landfill gas extraction is one of the main forms of biological treatment that we have now across Australia. Anaerobic digestion is another key technology which is suitable for a clean organic stream. The benefits of anaerobic digestion is it actually can produce a fertilizer from the digestate as well. If we can go to the next slide, please. So talking through in a little bit more detail the thermal treatment process, essentially it's quite similar to a conventional coal or gas combustion process. So the waste is actually combusted at high temperatures to generate heat. The heat produces steam, and that is used in steam turbines to either generate electricity or for heat supply. And really where the technology and a lot of the effort and complexity comes into these processes is in the flue gas treatment. So this is the treatment that's done from the gas to clean it up before it gets released to the atmosphere. Now, this includes ammonia injection into the combustion phase to control the nitrous oxide levels, and then further on through the process, the addition of lime to neutralise any acidity in the gases and activated carbon that helps to absorb the particulates. So the gases then pass through a baghouse filter, which captures those particulates prior to the release of the cleaned gas to the atmosphere. And this process basically uses the embedded energy within the waste as an alternative to fossil fuels. So essentially 3 tonnes of waste can replace 1 tonne of coal in terms of this process of producing electricity. And what that does is it creates a lower carbon energy solution, and it also reduces the need for landfills. So if we can go to the next slide, please. So in addition to energy production, the other outputs through this process are bottom ash, which is approximately 20% of the inputs, and that basically consists of the non-combustible materials, so things like stone, grit, glass, and rocks. And what can be done is they can be further processed to produce an aggregate, which can replace virgin material in the construction industry. And part of that reprocessing of the bottom ash also creates the opportunity to extract metals, so both ferrous and non-metals, about 2%. Can be extracted from the bottom ash and then used for recycling. So what's left at the end of that is basically the residuals from the flue gas treatment, and this is where the contaminants are captured, and suitable end use for that is for disposal on site. So when you look at that all together, what this can achieve is greater than 95% diversion from landfill. So if we can go to the next slide, please. I'd just like to give you, I suppose, an example of the journey as I see it in terms of waste management. And this is, so Woodlawn Eco Precinct is a facility that Veolia operates and has been operating for almost 20 years now. So it's sort of telling a bit of a story about how we have progressed over time. And that facility started out as a bioreactor landfill, basically using a degraded mine site, so a void, a mine void that had been created, and as part of the process of rehabilitating that, using that as a landfill, extracting the gas from that site to produce renewable energy. And I guess rather than just finishing there and saying all we're doing is landfilling waste, there was a long-term vision, I suppose, in terms of what else could we do. So now having a presence on the site, what else can be done? And as a result of that, what we've done is utilise that waste heat that's a result of the electricity generation to develop an aquaculture farm. So that aquaculture farm, actually, we grow barramundi and sell that into the Canberra market, which is the largest local market for this site. On site, we've also been able to develop other renewable energy sources. So we have, there's a commercial wind farm that's operated by a third party on site that generates renewable energy back to the grid, and also a solar farm that supplies the majority of the power demand for the site. The most recent addition to this facility is a mechanical biological treatment plant. This plant processes mixed waste and produces an organic material that can be used in the rehabilitation of tailings dams. And I guess the final step, or the next step that we see in the process of this site, is the potential development for an energy recovery facility that could result in an additional 30 megawatts of renewable energy generation from the site. So if we could go to the next slide, please. I guess just looking at, having an energy recovery, facility or activity on site creates other opportunities, and one of those other opportunities is to capture carbon dioxide from the process. What this has the potential to do is to further reduce greenhouse gas emissions and possibly even create a carbon negative facility. So when we're talking about thermal treatment, the flue gas typically has about 5 to 15% of carbon dioxide in it, compared with landfill gas, which is typically about 50%. So there's significant opportunity to actually, if we can capture that carbon rather than release it, and then also find a use for it. So in terms of reuse opportunities, this really is a new and emerging technology, and it's continuing to be developed. And what you can see here is some of the potential uses for that captured carbon, in the form of carbonation, also building products and potential for fuel. So these are really emerging technologies, and over time I see it as a real opportunity for us to really improve those greenhouse gas capture outcomes. We have the next slide, please. So finally, I guess I'd just like to be able to finish on a Korean case study. Now, full disclosure here, I have to say that I'm part of the Australia and New Zealand part of the Veolia business, so I'm by no means an expert on what we do over in Korea, but my Korean colleagues kindly gave me an example of something that we're doing here over there, which I think is really exciting and innovative in that energy recovery space. So what we're doing is we're using pyrolysis to process artificial marble waste, so the offcuts and dust that come from, might be a table bench top, the kitchen bench top, and recycling that into methyl methacrylate, or MMA, and aluminium oxide for use back into the building industry. So MMA can be used in acrylic lighting and automotive lamps, and aluminium oxide can be combined with silica to use for raw materials in ceramics. So that's just another different example, I guess, of the things that Veolia is trying to do globally to look at different opportunities. And I think it's really encouraging to see that there's different ways that energy recovery can go in terms of technologies. But I guess the overall outcome and the significant impact that I see it making is being able to not only improve on recycling or recovery rates overall, but also reducing greenhouse gas emissions. Thank you.
Oh, that was fantastic, Christine. And you just threw that last little bit there in as a teaser at the very end. Wow, what's going on in Korea?
Don't ask me difficult questions on that one.
No, I was going to say that's pretty phenomenal, amazing. So I had a couple of questions I just wanted to ask you. So apart from when you showed the map of Australia, which was showing the landfill levy, the landfill levy prices, and obviously the rates, some of those rates are quite prohibitive. Being, the highest one was what I think $147. I think it was, and that was in New South Wales. I think I saw that. Apart from the landfill levy, which is obviously prohibitive and very expensive, what other, what other sort of would be the biggest challenge, do you say, for implementing energy to waste is from energy from waste initiatives that you see in Australia? What would that be? What would that look like to you, other challenges?
Yeah, thanks for that, Ricky. So as you pointed out, the economics is really a key part of it. I guess the two other key areas that I would say, one being the regulatory framework. So not just from an economics point of view, but really sort of having an environment that really supports the opportunities for value add recovery that can come out of this. So looking at opportunities about the byproducts that come out, what can we do to reuse to capture more carbon? So actually being supportive and I suppose it's government and industry working together to try and come up with those initiatives, I guess, is another opportunity. But I guess probably the key, sort of the crux of all of this is really the community. So from a social point of view, actually any of these facilities, we really need to go on the journey with the community to actually understand what these technologies are about and take the time to actually work through that and make sure that, that everyone is comfortable and understands what it is that we're trying to do. So, yeah, I would say that's probably the main thing that needs to be done for us to take the next step.
Yeah, it's interesting, isn't it? It's all about communication and education, about getting that out there. Yeah, exactly. Which is, I always come back to that it's about getting people on board, people power to make change. So that's fantastic. Look, I know you practice what you preach as well, like Yoonah, and all of you are, amazing with what you do. I'm sure we'll have some questions there, particularly about the Korean little case study that you showed us as well. And I'm really interested to see where the carbon capture reuse, that whole part that you said that's the next part of the journey with what you're doing in Woodlawn, which is going to be really interesting to watch and see where that space goes. So thank you very much for your fantastic presentation. We'll keep moving on. We've got one more wonderful speaker today, and then we'll have a little bit of a Q&A. So without further ado, I'd like to introduce Mr. Richard Romanowski, who's the co-founder, executive director for EleXsys Energy. Richard is a performance-driven senior executive in the renewable energy and clean tech sectors, delivering transformational business strategies to bring innovative ideas to market. Richard has been and is applying his experience to establish EleXsys Energy in international markets where renewable energy displaces conventional carbon-intensive energy. EleXsys is an advanced power electronic device integrating a suite of AI, artificial intelligence, proprietary software applications, enabling next generation two-way smart grids. And I know that Richard's going to talk about a case study, but I know he's also got a little announcement that just came out today. So that'll be really fantastic for you to share that with everybody. So the case study today is going to be on carbon neutral solutions enable multinationals to achieve sustainable development goals. Really, really on topic right now with what's going on here, particularly in Australia. So over to you, Richard, and look forward to hearing what you're going to say.
Mute. Can you hear me? Hello, everybody. Do I do that again?
Yeah, we can hear you.
Thank you very much. It's fantastic, Ricky, for the introduction, and Yoonah and Christine. It's wow, they're really impressive things you're doing. I love the theme, no time to waste. That's what we started this company for, that same reason. We radically speed up decarbonization of the local grids, not just in Australia, but globally. We do this around the world so that we allow for a huge increase in the amount of renewables that we can put into the local grids and basically solve there's this thing, you'll hear me talk in the next few slides about solar curtailment, that, energy flowing backwards into the grid just doesn't work. And that works for Christine too, because when we're putting these waste to energy plants, the best place for them is within the local suburbs. And then they have this thing called solar curtailment. We have won the Davos Energy Startup Award in 2021. We won the World Energy Council Startup Award in 2019. We've developed this technology in conjunction with Griffith Uni and CQ University. And we've even sponsored something called the ACE Hub, the Australian Circular Economy Hub. So we're really committed to this space of speeding up and no time to waste. Next slide, please. So just imagine if we put rooftop solar on every single house and building in Australia, we can generate 120% of all our electrical needs. And that's the same all over the world in terms of the Sun Belt. It can't be done because the grid is a one-way grid. It cannot handle all that energy going backwards. It's a bit of physics, right? Really complex physics. Next slide, please. And this is the key, is when you start, so in California, they're way behind, well, pardon me, let's say Florida, they're way behind us in Australia. This problem of backwards energy, and the grid can't handle all your energy going backwards, only happens when you get to about 15% of the rooftops in your neighborhood have solar. The first 15% of customers get this fantastic, I get all my energy, I get all my feed-in tariff. Once you hit 15%, you get this problem called curtailment, which I'll explain more as we go forward. And this is happening now in Australia, Vietnam, Hawaii, all over the world. What that means for, I'll just use a residential example. In Australia, when you install rooftop solar, you think you're going to get a three-year payback, but you're really getting a 5 or 7 year payback because the solar inverter and the grid is actually reducing the amount of energy you can send into the grid. Next slide, please. But our technology fixes it. We turn the one-way grid, we change the fundamental physics of the grid and turn it into a two-way grid with our power electronics and software. So that really increases the return on investment. I'll show you in a second. We can create 10 times bigger projects, and we can do that without huge cost to the grid. Next slide, please. This is our IKEA cornerstone project. And I'm sitting here, I'm usually trying to turn on a stopwatch so I don't ever go past 10 minutes, which is my time, but I forgot to do that. So I hope I'm not going to go too long. So this is our IKEA flagship site in Adelaide, where we're demonstrating all our concepts. And we're able to fill the roof with solar. The whole project is 10 times bigger than what the current smart inverter and the grid constraints will allow. So if you were to do this today without EleXsys, you'd only put about 500 kilowatts of solar on the roof. With our technology, you're basically putting, with the solar and battery, you're putting 5 megawatts. You're turning this into a mini power plant. And 70% of the energy goes backwards. This thing called uncurtailed is crucial. That means when I send that energy backwards, I'm never going to get any constraint. When I send 1 unit of energy backwards, I get paid for 1 unit of energy. In the grid, when you send energy backwards, you get curtailed. I'll show you that more later. The key, though, is that this becomes bankable. So it's not owned by IKEA, it's owned by the pension fund. Without bankability, then it doesn't release the ability for this trillions of dollars of pent-up money around the world to invest into this new asset class called distributed energy. Next slide, please. So the next phase, stage 2 of IKEA, is we're actually putting in a solar car park, EV fast charging, converting all their delivery vehicles to EV, and it will become a net zero on-site. From on-site generation, they will be net zero. So it's a huge part of going global in terms of decarbonization. On top of that, they'll save 25 to 35% of their energy costs, as opposed to buying energy from a solar farm, which you don't really save any costs. So this is huge. They're going to scream about this when we get that far and deliver and prove it. They'll scream about this from the rooftops. And this is effectively where we can turn some industrial and commercial sites into net zero from on-site generation. Next slide, please. This is a discussion around this thing called curtailment, sending energy backwards into the grid. It's a hard concept to understand, but basically it's like a big water pipe, and think of rooftop solar. You're trying to send energy backwards up this big water pipe that's going one way. And so what happens is you have this thing called congestion and whatever, but it means that your rooftop solar doesn't actually deliver the energy or the income that you thought. So in a 1 megawatt example, which is like the IKEA and other big commercial sites, they could lose 10% to 50% of their annual income because of a curtailment. We fix that problem. Our technology sits beside the solar inverter. We fix it, we make it work. It's guaranteed backwards energy. It also works for waste energy. It works for microgrids. Next slide, please. Then this is the complex slide. I apologize. There's no way of making it simple. This is the 1 + 1 + 1 = 5 slide. You fix the curtailment, the backwards energy. Step 2, that then lets a third-party financier to step in and start funding. You need that. Step 3 is you need that funding because globally 80% of all buildings are owned by someone else, and they have a tenant landlord problem. They call it the split incentive. So when you have a split incentive, no one wants to pay for the air conditioning upgrade in the middle of the lease. So it's just this, it's been there forever. So you need a third party to walk in and fund solar and batteries. Well, we make that happen because we make it bankable. Then in Australia and in many of the places around the world, we can add batteries in without a grant. It's huge. And we end up with a 10 times bigger microgrid, and basically moving the solar farm from out in the country, out in the sticks, into the city, onto the rooftops. So back to that starting point, think of that vision. If we filled all our rooftops with solar and then we added batteries, we can power our whole communities, mostly around the world, with clean energy. Next slide, please. And this is not just Australia, this is global. We are going global. EleXsys is a global company. In Australia, we go to market with Planet Arc Power, is our master licensee, but EleXsys is the global brand name. Here is an example of Vietnam. In Vietnam, in 1 year, they went from 764 megawatts of rooftop solar to almost 9 megawatts. Anyway, so you can see the difference. Huge, massive increase. But guess what? Everything got curtailed, so they're losing 25% of the energy, and so we're going to put EleXsys into those sites and fix that problem, so that energy doesn't get wasted. It doesn't just go up and poof into the air. Next slide, please. And our model to scale globally, because there's no time to waste. There's no time to waste. We need to do this fast. I don't want to do this in the USA and whatever. I'm actually licensing everybody around the world to do this. We're looking to become the Intel inside of the global, local, renewable supply chain. So we're looking to license Veolia, Vinci, Engie, all the global big companies and the small local companies to use our technology, build 10 times bigger microgrids, fill every rooftop with solar. They make money, we make money, and we save the planet at the same time, is what we're doing as our vision. Next slide, please. And guess what? There's a whole bunch of smiling faces. So we're a team of 55. We're now about 65 people. We're already global. We have London, UK, North America, Singapore offices. Our executive team are, 7, 8, 9 vice presidents from Schneider, Siemens, and all over the place. So we're ready to go global, and that's what we're doing. And we're there changing the world because there's no time to waste to decarbonize and save the planet. That's me. I'm finished. Thank you.
Wow, that's what I think. That's amazing. You touch on so many points there. I've got a zillion questions, but I do want to ask you one just fun question before we get started in some of the other areas. Would you tell me how you got your nickname called, I think it's Snap Frozen Yank, I think, when you came here? Could you tell us where that's from? Because obviously we can tell you've got a little bit of an accent.
I have an accent that when I arrived in Australia, my lovely wife is a Brisbane girl. She brought me back from Canada. We arrived back in Australia about 32 years ago, and everyone assumed my accent. Almost everyone assumed my accent was American, Yank. So they kept calling me a Yank, and I kept on responding that I'm Canadian. I'm not a Yank. I mean, you hurt my ego. So then one woman said, but that's no big deal. You're just a Snap Frozen Yank. Don't worry about it, right? And so it's sort of stuck. And it's the Australian. It took me a while to learn this Australian colloquialism where they make fun and all that sort of stuff. And it was all said and done in fun and not. So originally you take it as being, but so I'm a snap frozen yank. How's that?
Yeah. And you know, that was, and you said that's 32 years ago and nothing much has changed. We're very much like that. And I think you're a little, you know, not only you're a little bit of a trickster with your accent, with the Canadian American, you've also got a photograph behind you of Sydney Harbour, and you're actually based in Brisbane. So you've got some little things going on there just to keep us guessing. But what I did want to ask you, first of all, your presentation is amazing. There's a lot of really interesting touch points there. And as you said, you know, you're trying to move quickly to get this, you know, go global, and you've shown, you know, some examples there. I have two questions. One's an easy one, which is, where is that IKEA plant that you mentioned that you used as the example? Whereabouts is that in Australia?
That's in Adelaide.
That's in Adelaide, okay.
We are discussing with IKEA to go to use, to extend to all their sites in Australia, and we're also discussing, you know, they want to look at, you know, the early stage discussion. They're looking at doing more sites, so it's pretty. They're pretty interested.
Okay, no, I just thought I'd ask because didn't know where that was. And the other one, which you sort of answered, but I guess just really quickly in sort of 30 seconds or less, so we can open it up to the floor. What do you think is the biggest barrier for you to that's holding you back to actually going global? If you could do that, you know, in 30 seconds. With your, you know, with decarbonisation and, you know, local renewable energy.
I think a lot of it is the embedded energy self-interest. There's so much that we're dealing with and we've never thought about it as a society. You know, you walk into a room, you turn the lights on, you don't even think where things are coming from. And now as we democratize energy, it forces everyone to start thinking of where things are coming from, and the vested interests are very powerful. It's not easy to make them change. Our technology bypasses a lot of those vested interests.
Okay, fantastic. So on that note, I won't ask any more questions. I'm going to, first of all, thank everybody, our speakers, but I'm going to flip over to my co-host, Sharon, and ask Sharon if you've got any questions from the chat that people would like to ask any of our speakers.
Ricky, there's a couple of questions that came up in the chat over time that we could actually pose to our speakers, but I've just got one for Richard first. How do you overcome all of those vested interests, Richard?
Oh, it's never easy. Thank you. Can you ask me a simple question? I think the best thing is we're patient and we're about 35 engineers, so we can speak to the electrical utility engineers at their level and slowly convert them to, wow, this is actually possible and can be done. Remember, these guys have got 30 or 40 years or 50 years of training, and that the sort of stuff what I'm talking about can't be done. So one is patience, but very much technical training or education and proof of concept. The other thing is we have social license. We forget that these guys have a social license to deliver services for us, like the fire department. Just think of the fire department. So we're working also with the various societal regulators, politicians to say, hey, there's a social license here. They need to deliver the least cost, best solution for society, not gouging society and gold plating the grid. So there's two drivers that are helping us facilitate, but gently and quietly and respectfully, change.
I think you did a fabulous job of what was a very difficult question there, Richard. Well done. That's amazing. I've got a question for Dr. Jeong, and it's a slightly technical question for you. What is the mass yield of food waste biochar compared to raw food waste? So a question that came through in the chat during your presentation.
Yeah, let's see. I'd like to note that low mass yield is good news for the production of biochar because low mass yield implies the reduction of volatile matter from biochar, so it means good quality. Mass yield of food waste biochar largely depends on pyrolysis conditions, and it is safe to say about 20 to 40%. And mass yield of food waste biochar decreases with an increase of pyrolysis temperature. So I think that would be an answer.
That's wonderful. Thank you so much. And there's another question in the channel for Christine, and I'm not sure if you can answer this one, Christine. We know you're not the Korean expert, but could you actually just explain a little bit more about the model that Veolia suggested to Korea to implement 3 plants? And feel free to tell us if it's beyond your capacity.
Thanks, Sharon. Look, I probably can't go into too much detail about that, other than I suppose to say one of the key elements of this is finding an end use, I suppose, for whatever product it is that you're making. So that's not dissimilar to, I suppose, any sort of technology that you're trying to implement. So trying to marry up the solution for the specific waste or problem that you might have, and then making sure that there's an outlet there for it. And that you can meet the specifications that are required for that. So yeah, without going into too much detail, but the need to make sure you can actually meet the outputs that are expected of whatever it is that you're doing is obviously a key part of it.
Oh, that is fabulous. Thank you, Christine, and thanks for kindly sort of trying to tackle that question. Ricky, we have no more further questions from the audience, so I'll hand back to you.
Thank you. Thanks. That's great. And obviously there is so much that we could delve into, but unfortunately, we just don't have the time. So what I'd like to do is obviously big vote of thanks to all of our amazing speakers. So Richard, Christine and Yoonah, thank you so much. It's amazing. And you've really opened up probably a can of worms for us all to have a bit more of a think about. That's what this is all about. It's about driving change and moving forward. So thank you very much. I would like to announce our next event, which will be our wrap-up event for this series for this year, and that'll be session 3, series 3, session 3, and that's going to be August 24th from 12 to 1 o'clock. And again, we've got a really fantastic lineup of speakers. The theme is about the final session is climate technology and national plans for a carbon neutral future. So it sort of segues really well again from what we've spoken about today in our first session. It'll discuss obviously Korea's vision to build on the fundamental elements for a sustainable and carbon neutral society, and look at the partnerships and cross-sector bilateral arrangements and what we've got going in Australia, and leverage future demands in that area. So it's going to be quite a really market global driven supply chain talk fest for that last one. The panel of speakers are Dr. John, Director of Division of Climate Technology Corporation for Green Technology Centre. And of course, we've got Professor Mark Howden, who you can see there on the screen, Director of the Institute for Climate, Energy and Disaster Solutions, the Australian National University. And then of course, Mr. William Bloomfield, who's the Acting Director, and he's also here in Australia, the Climate Innovation Investment, Australian Department of Foreign Affairs and Trade. So we hope that you will join us for that as well, because that'll be a really wrap up of our Korean series for the 3 sessions, just in not very long, in less than a month. So we hope you can join us for that. And on that note, I also would like to just add a little note. You know, I started talking at the beginning of the presentation about, you know, people in lockdown and how the webinars we started them last year to sort of try and bring people together and get people to stay connected with what we're doing. And, you know, we think a lot at Plastic Oceans Australasia, we think a lot about how we can keep communicating and educating and helping people, particularly with the whole plastic space that we're all in. And I would like to invite you to join us in September for our Picnic Unwrapped campaign. And we'll put a little tag in the chat line for you to join us, because I really want people to get together and try and make a difference. Even every day we do something. And as Robert Swain said, and it's fair to say both Sharon and I concur, the greatest threat to our planet is the belief that someone else will save it. And that's been a problem for many, many decades. We always think someone else is going to do it. So if everybody could host a picnic of some sort, whether you're in lockdown or not, or outside, inside, wherever you are, it would be fantastic because you can all play a little part, get together, share with your friends, share with your colleagues, and actually keep driving change, which is why it's so fantastic that you're joining us today. There will be a podcast available, as always, on our POA website and event video on social marketing at Griffith, YouTube channel and Plastic Oceans channel. And again, thank you so much. Thank you to the team behind that does all the hard work to get these together every session, and really, really appreciate you all being here today. So thank you so much, and hope you enjoy the rest of the day and the evening to follow. And thank you to our friends from all over. I see we've got people from Dubai, Seoul, all over the world. So thank you so much for joining us.
It was great to have you here today. Thank you.
Bye-bye.